Please read this paragraph right here and write something quick about this prompt. If getting an 80% on a test is the same thing as scoring in the 80th percentile. So go ahead and do that. Alright, now that you've done that, hopefully you've said something that no, they aren't the same, because an 80% tells you the score you got, but it doesn't tell you how you compare to the other students who took it. Being in the 80th percentile means you did better than 80% of the other people, but that still doesn't tell you what your score was. So in data set 1, an 80% would be the lowest score out of everybody who took that test. So no, that basically is not a good score. It's the worst out of everyone. But if we look at data set 2, an 80% was the highest score because everybody else did much worse. So you can jot down some explanations to those. You can go ahead and watch that video by clicking on the link and then just take your notes in those two boxes and then figure out what you learned about percentiles. Now that you've done that, let's see if you can actually figure these problems out. You should have learned that the first thing you do is count up the number of items you have in your list. I always number them just so that I don't have to recount them later. 6, 7, 8, 9, 10. Okay, so there's 10 items in the list. The 50th percentile is the decimal 0.5 for 50 if you move the decimal 2 places. We're going to multiply that by the 10 items in the list, and that gives us 5. That means that the 5th number in the list will be the 50th percentile. Well, since I already labeled them, I can easily see that the 5th number I labeled was a score of 90. Let's see if you can do this one. Hopefully you're numbering those scores so we can see how many there are. And it looks like there's 10. We want the 20th percentile. So we take the 20 and move the decimal 2 places. So we're going to do 0.2 times the 10 items in our list, and that gives us the number 2. That means the second number in the list is the 20th percentile, so a score of 80. Oh, one thing to keep in mind, these problems were set up for you, but those numbers are in order from low to high. Make sure you have that before you start. If you would like, you can click on these links here, here, and here, and figure out your IQ. You don't have to, but it sort of ties into example 3. But what we're going to look at is this normal curve right here. So we've seen this bell-shaped curve, and anytime you have something that's normally distributed, and most of the time if you have enough data, it'll fall into a curve that looks like that bell shape, then we always have a certain percentage of all the data falling within a certain number of standard deviations. So yesterday we learned that a standard deviation is a typical amount that your data varies from the mean. So the mean, your x bar, always goes in the middle, and then however far your standard deviation is, that would be one standard deviation away, that would be another standard deviation. The percentage of your data that falls within those standard deviations gets smaller and smaller the further you go away. The same thing for being lower than your mean. That would be one standard deviation away from the mean, 2, 3, and 4 standard deviations below. So when we talk about data falling within a certain percentile or within a certain number of standard deviations, if you want to be within 1 standard deviations away from your mean, that means you're plus or minus 1 away. So we take the 34% and the 34% and add them up, and you'll see we get that number down there, 68%. Numbers that fall within 2 standard deviations would be from here all the way over to there. If we took the 13.5, those 34s, and that other 13.5 and added them all up, we would get a total of 95% of your data falling within 2 standard deviations. And then the last one is within 3 standard deviations. So that would be anywhere from here all the way to there. So if we add up all those percentages, the 2, the 13.5, the 34, the 34, the 13.5, and the 2, that will give us a total of 99%. So really only 0.5% and 0.5% of your data falls more than 3 standard deviations away from your mean. So if you read the IQ test, you would have seen that the mean score on an IQ test is 100, and the standard deviation is 15. So we're going to start off by putting the mean in the middle, and then we'll go above and below 1, 2, and 3 standard deviations. So if we add 15 to that, we'll be at 115, then 130, then 145. And when we count the other way, when we subtract 15 from 100, we'll be at 85, 70, and 55. My advice is to always put in those percents. This will always be 34, 13.5, 2, and 0.5. Same thing on the other side. It'll be symmetric. Now we can answer the questions. What percent scored above 115? All we need to do is look at the percentages that are all above 115. So everything on this side. So we'll add up the 13.5, the 2, and the 0.5. When we add all those up, we get 16. Now between 100 and 115, that looks like it's just between here and here. So 34. Now between 70 and 100. Alright, that'll be from here all the way over to there. So we'll add 13.5 and 37, and we'll get 47.5. Next we want below 115, so we need to add up everything from here all the way back. From here back. So the 0.5, the 2, the 13.5, the 37, oops, that should be a 34, 34 and 34. We will get 84 for that. Above a 130, that'll be the 2 and the 0.5, so 2.5. And now we need to figure out how many scored between 100 and 115. How many people? Well, we know 34% of the people scored between those numbers, so all we have to do is figure out what 34% of, so we'll multiply the 500 people who took it. When we do that, we will get about 170. Last, we want the people who scored between 70 and 100. Well, when we look at those people, from there to there, that red line, it'd be 13.5 and 34. So that was 47.5% of the people. Well, we need to figure out what percent of 500 is 47.5. So we'll change that to a decimal, 0.475, multiply it by 500, and we will get a decimal. We're going to get 237.5, but let's just round it up so it makes sense. Let's just round it up to 238. For the last problem, the last example, I'm going to come out and tell you that the mean score, the average score for ACT students, 300 people took it, the average score was a 20. The standard deviation was 5.2. So take that information and label the curve. The mean always goes in the middle, and then we'll count the number of standard deviations away. So we'll add 5.2. So we'll be at 25.2. We'll add another 5.2. That'll bring us to 30.4. And then we'll add another 5.2. So we'll be at 35.6. Then we'll count the other way. We will subtract 5.2 from 20. That will bring us to 14.8. Subtract another 5.2, we'll be at 9.6. Subtract another 5.2, and we'll be at 4.4. I'm just going to label those percentages. 34, 13.5, 2, and 0.5. Same thing on the other side. 34, 13.5, 2, and 0.5. And now we can use that to figure out these scores. We want lower than a 25.2. So that's everything from here back. When you add up all those percentages, you should get 84. Lower than a 20, well, 20 is right in the middle. So half the data is lower than a 20. I'm not even going to worry about calculating it out. They should add up to just about 50%. Lower than a 14.8, let's see, we'll just need to add the 13.5, the 0.5, and the 2. That will give us 16%. Between 14.8 and 25.2, let's see, that's the middle right there. Those are all within one standard deviation away, so 34 and 34 is 68. Now between 14.8 and 30.4, so we're adding just that 13.5 on, so basically 68 plus 13.5, that'll be 81.5. Greater than 30.4, that's just way out there, 2 and 0.5, so 2.5. And now for the last ones, we want how many people scored between certain scores. Well, the number of people between 14.8 and 25.2, we have to figure out what percent of the people scored there. 68. So it'll be 0.68 times the 300 people who took the test. That will give us about 204 students. And last but not least, how many kids scored greater than a 30.4? Well, that's a pretty hard score to get, so not that many. We'll change the 30.4 to a decimal, 0.304. Oops. Just kidding. You figure out the percent of kids who scored greater than a 30.4, and that's 2.5. So we take the 2.5 and change that to a decimal by moving it 2 places. So it will be 0.025 times the 300 people who took the test. And when you do that, you get 7.5, or you can just round it to 8. Good luck on your homework.